Welcome to my channel. My name is CHAKI'S and today's lesson is going to be on shear force. Now before I go into what is shear force, we need to understand what is shearing. So what is shearing? We'll see that. Let us take a rectangular block. The corner of the blocks are A, B, C, D, E, F, G, H. This represents the corner face of the block. Also, we are fixing the bottom surface of the block and the longitudinal axis of this block will be representing the y-axis. Therefore, any plane perpendicular to the y-axis or longitudinal axis will represent the cross-sectional or transverse surface area. Now, we are going to apply a load P which is tangentially along the top surface area. In this case, P is the force which is acting tangentially to the top surface of this block. Now this top surface is also called the cross-sectional or transverse surface area. Now for equilibrium of this block, the bottom surface will provide a tangential reaction P which is equal and opposite to the applied tangential force. Now we are going to take a cross section. Here this is the cross section and we are going to divide this body into two parts. This is part 1 and this is part 2. So from this diagram, that is from part 1 diagram, we can see due to the application of this force P, a resisting force is acting at the bottom of this part 1 and this will be in equilibrium as long as R is equal to P. Similarly for part 2 block will be in equilibrium as long as R is equal to P. Now, all forces acting tangentially along a surface or along the cross section is known as shear force. So here R, which is the resisting force, also the shear force. Now we have seen that the body will remain in equilibrium as long as R is equal to P. So P is also a shear force. Suppose a condition happens such that P becomes greater than R, that is the resisting capacity of the body is not able to resist the force P. So the equilibrium cannot be maintained, so the body will split or break off into part 1 and part 2. That is, this body will permanently break off. So we can say that part 1 and part 2 will represent the equilibrium condition of the body just prior to failure by splitting or breaking off of the block, which is also termed as shearing. Therefore, if we consider this to be a single unit, this particular movement, that is this splitting of these two blocks, is called shearing. In this case, I can see that the shearing is taking place only when the load P is applied in such a manner that it is perpendicular to the longitudinal axis and parallel to the transverse axis or the cross-sectional surface area. So it is one of the criteria to say that shearing or breaking off or splitting will occur only when an external load is applied on the body which is parallel to the cross-sectional surface area or transverse surface area. Now we have only considered one load which is P in our case, but in practicality there can be more than one load which is acting perpendicular to the longitudinal axis. So if I say that P is equal to summation of all the forces, then I can also say that R is the summation of all forces either from top or from bottom. Therefore, R is the internal force which is the resisting force developed in the section XX. This is the region XX. R is developing in the cross-sectional region where we have considered to take the cross section to maintain free body equilibrium. Now this is the 3D structure. Now we are going to go to the 2D structure. So this is 2D. X-axis and Y-axis is considered. Here what we are doing the same thing in 2D. Say ABCD is the rectangular block which is fixed at the bottom face AB with the surface. Okay. A force P is applied tangentially along the top face CD, which is parallel to the cross sectional area or transverse area, whatever we say. Now for equilibrium of the block, the surface AB will offer a tangential reaction P, which is equal and opposite to the applied tangential force P. This and this is equal. Now consider a cross section. Here we are considering the cross section XX, which is parallel to the applied force. This cross section is taken parallel to the applied force or parallel to the cross sectional or perpendicular to the longitudinal axis of the block. So part 1 and part 2 will be equilibrium if P is equal to R. Similarly, if we take P to be the summation of various types of forces, R also will be the summation of various type of forces. So R is the resisting force. Therefore, I can say that R is a shear force at a section XS is summation of all the transverse component of forces either from top of the section or from bottom of the section. Also, R is the internal force which is developed at a section in order to maintain free body equilibrium of element either from top of the section or from bottom of the section. I can say that. So here you can see the representation of the resisting forces. If XX is the cross section, at the top of the section this resistance R is acting along the negative x-axis, and at the bottom of the section this resistance R is acting along the positive x-axis. So both the forces are equal and opposite to each other, and it is represented by this. We are going to apply the same concept to beam to know what is shear force in a beam. Shear force. Now if we take a beam, this particular block to be a beam, this is the longitudinal axis of the beam and this is the transverse axis which is parallel to the cross sectional area. Point A is hinged, point B is roller. It is a simply supported beam where a point load is acting. Now if we take the section XX, we can see that in the left SX, which is the shear force at section X, is acting downward, and at the right it is acting upward. So what is shear force? It is the internal property of the section or the beam. Here we have considered beam. So shear force is actually the internal property of the beam to resist any external load such that free body equilibrium of the section can be maintained. So if we take this to be our beam, here we are considering this to be our beam, a load is acting such that the beam has a tendency to break off or split off in this way. I am going to repeat my hand movement. It is breaking off in this way, or it is breaking off in this way. This is called shearing. Therefore, shear force is the internal force which is developed at a section to maintain free body equilibrium. That is, it is resisting the externally applied load in such a manner that this shearing phenomenon does not happen. So the same principle can be applied here, that Sx, which is an internal force or a resisting force which is developed at a section in order to maintain free body equilibrium of the element either from right or from left. Also, shear force at a section is the summation of all the transverse component of forces either from left of the section or from right of the section. When calculating Sx, we can say that it is the summation of all the transverse component of forces. Now I can say here there can be another load or there can be multiple of load acting in this section. So for Sx, we are going to say it is the summation of all the forces either from right of the section or from left of the section. This is the sign convention. Now if we take the cross section and see that the force, that is the direction of the shear force, at the left side is acting upward and at the right side it is downward, then shear force is termed as positive shear force. Also, if we take the cross section and see that at the left hand side the shear force is acting downward and at the right hand side shear force is acting upward, it is taken as negative. Thank you. That's it for today.